Hey, welcome to this bonus video on polynomials. In this video, I just wanted to take some time to review pieces of polynomials, important features, and features of polynomial graphs that may have been covered in the sections prior to Chapter 5. But since Stretch College Algebra 2 begins at Chapter 5, I thought it would be prudent to review some of these concepts. So the first thing we're going to talk about is just different features of a polynomial function. So as we know, a polynomial function is just some function that looks like a combination of powers of x that are either multiplied and added to one another. The biggest power on an x, in this case, it's 2. That is the degree of our polynomial. So this polynomial is degree 2. And then the term in front of that degree 2 term is known as the leading coefficient. And finally, this last term, the 1, tells us what our y-intercept is. For polynomial theory, we're typically safe to ignore kind of what's going on in the middle, except in cases of factoring. But when we're just analyzing the behavior of a polynomial, it's most important on what's going on with the largest term and what the y-intercept is. Okay, so that's our basic review for what the function looks like. And now we're going to talk about pieces of a graph. So a polynomial graph usually looks something like this, where it intersects the x-axis a few times, intersects the y-axis exactly once, and changes direction. Polynomial graphs are continuous. That means they don't break away. They have no gaps in them. They're just a continuous line that you could draw with a pencil without ever picking it up. In this problem in this graph, we have 2 intervals of where the function is increasing. So if we remember, a function is increasing on an interval if the graph is going up. So as we move towards the right, the output of the function is getting larger and larger. And we also have 2 intervals on this graph where the function is not increasing. And hopefully you remember that that means the function is decreasing. So as we move towards the right, we're getting smaller and smaller numbers. On this graph, there's a couple of special points associated with increasing and decreasing where the function is neither increasing or decreasing. These 3 special points occur right where it changes from decreasing to increasing or increasing to decreasing. And they are what we call turning points. Hopefully you can imagine this name is derived because the direction the arrow is going has turned. So it was going down and now it's turned to go back up. Also on this graph, we have 3 x-intercepts. Sorry if the drawing's getting a little messy now. So these are x-intercepts. I'll usually abbreviate it to x-ints to save space. And then they also have 2 other names. There's zeros as well as roots. All right, our textbook often calls them zeros when you're talking about them with a polynomial. And a 0 is an x-intercept on a graph. So when you're looking at the graph, it's actually an x-intercept. Our book makes no mention of roots, although roots are a standard terminology and are used almost everywhere through math when talking about zeros in this case. And I will also often default to calling them roots. I'll try to make an effort of calling them zeros, but if I mess up and say roots, they're exactly the same thing. And finally, the last important point on our graph is right here. It's this y-intercept. And again, because functions have to satisfy the vertical line test, there's only ever one y-intercept. And then the very last thing to point out with the graph is that these arrows indicate our end behavior. So it tells us that as the function's going towards positive or negative infinity, the function itself is going towards infinity. All right, so that's just a quick review of pieces of the polynomial function as well as the graph that will be used extensively throughout chapter 5. All right, thanks for watching this video.